So this is just a simplified diagram of an arch. And like I mentioned before, the Romans became quite adept at placing them together and realized that they could span much farther, um, longer distances by using the arch than just making something that went straight across like a bridge. So again, the pressure of the equal pressure is exerted by each stone onto its neighbor, and that's the whole point. That way you can go farther. And you're going to see several more images where the arch is the basis of almost all the architecture that you're going to see in the early days of architecture. Okay, here we have the Colosseum. It's an example of barrel vault or tunnel vaulting. The vaults, these are an extension of the depth of an arch, where they put a single arch together, lining them up one after another. The barrel vaulted created a large, uninterrupted interior spaces. The strength of the barrel vaulting structures allow more than 50,000 spectators to sit in it. This is an example of an amphitheater, a double theater, in which two semicircle theaters are brought face to face to accommodate large crowds. So this is the Colosseum, the barrel vaulting gallery. This is would have been around the outside, like a hallway, and as you look up, you can see the vaulting going on. So they basically made columns and lined them up. The groin vaults, Groin, created when two barrel vaults are made to meet at right angles, made possible by the Romans' invention of concrete. Adding volcanic aggregate to concrete mixture, it would set faster and be stronger, allowing them to create these huge, massive structures. So here is a diagram of a barrel vault at the very top. As I said, an arch that's been elongated. And then down at the bottom, we have the groined vault. And basically, like I said, it's two columns or barrel bolts put together perpendicular. You can think of it as a right angle. And that makes that long tunnel that we saw in the previous picture. It also strengthens and it allows the Roman architects to really build long, strong halls. Okay, here is the Pantheon. It is a wonderful example of a dome. Okay, the dome is at the very top. It takes the shape of a hemisphere, sometimes defined as a continuous arch rotating 360 degrees on its axis. The interior dimensions appear equal and proportionate. The scale overwhelms the viewer. The dome is concrete poured in sections over a huge mold supported by a complex scaffolding, 20 feet thick where it meets the walls. The springing, or the point where the arch or dome raises from its supporting dome, thins only to 6 feet at the circular opening. The oculus, Latin for eye, is the only source of illumination. Worshippers could make contact with the heavens, which I'm going to show you in the next picture. Here is the oculus, Oculus, Latin for eye. It's the only source of illumination. The worshippers were then able to look out into the heaven. It was framed by a circle. The interior space is only to be imagined. The viewer is confronted by the mammoth Corinthian columns made of polished granite raising some 121 feet. Can you imagine? This place it's huge, but from afar it looks like it's itty bitty, but then when you go inside it is awe-struck. Vast interior space evokes the symbolic presence of Jupiter. And that's also probably the reason why they used the oculus. Okay, this is the interior of St. Cyrim's Trelleus. This cathedral has barrel vaults in the Romanesque architectural style, great symmetry and geometric simplicity. The Romanesque preference for rational order and logical development. Every measurement is based on the central square at the cross, where the two transepts or side wings cross the length of the nave, the central aisle of the church used by the worshippers. The apse, the central circle projection at the end of the church, then is topped by a Roman half dome. Okay, this is Ames Cathedral, 1220. It's an example of a Gothic cathedral. At this time period, the architects are responding to the dark and dreary climate outside. The interior of the Gothic cathedral rises to incredible heights. It's lit by stained glass windows that transform a dull day with a warm and richly radiant light. The interior heights are anywhere from 142 feet and the total interior surface of more than 26,000 square feet leaves the worshipper in awe. The center of the nave is a complex maze. So I believe I have a video that will talk a little bit more about the Cathedral of Notre Dame in Paris. This is a pointed arch was used all over the Notre Dame. The great heights of the Gothic cathedral interior space is achieved by the means of a system of pointed rather than round arches. Here's the flying buttresses, the Cathedral of Notre Dame. Oh, this is just utterly amazing. I have been in this. This is the most beautiful church, cathedral. The height of the round arch is determined by its width, but the height of a pointed arch can readily be extended by straightening the curve of the sides upward to a point. The width descending much more directly down to the wall. This was the idea was to have it soaring upwards as if to God. Series of arches on the outsides whose thrust would counter the outward force of the interior arches. Those were called the flying buttresses.